Assalamu alaikum. Hello, everyone. We will continue our lectures. We are still in the topic of basic programming concepts. So we will get to know more about visualization tools available in C-born library. So let's start by, so we're gonna work with this example here. We're gonna load the data of this file basic4 clean.csv, and we're going to create a data frame from the content of that file, and we're going to work with different attributes, plot their statistics, and differentiated by values of other attributes and so on. Let's start. So let me first run this cell. Here what we are doing, as I said, we are loading the content of that file, and we are creating a data frame from that. We are displaying the information, and we are selecting 20 samples at random, and we are displaying them. As you can see here, the total number of entries is equal to the total number of of non-null for every column, so there is no missing data. And this data is a mix of object as well as numerical attributes. Okay, there are a number of numerical attributes as well as non-numerical attributes. So let's look at these samples here. This data is for some applications. Okay, here is the application name. Here is the category. Okay, is it like, for example, medical, tools, family, etc., social, okay, gaming, whatever. Here is the rating that is given to that application. Here is the number of reviews for the application, and here is the size, I think in megabyte. Here is the number of installs. So this one, for example, has been installed more than 100,000 times, so 100,000 plus. Okay, so this has been installed like 10 plus, more than 10 times. Okay, so the type of this, because of this plus here, the type of this is object. Okay, you can see that here. Okay, so this is what installs. Where is installs? Here it's object, so it's not numeric. Okay, and then the type of the application, is it free or paid? Okay, so there are two types, and if it's free, then the price is 0. Otherwise, if it's paid, the price could be whatever. Okay, so yeah, this is the price. The content rating. Okay, yeah, everyone for 17 plus, whatever. Okay, and here is generous. Okay, medical, tools, lifestyle, whatever. Yeah, well, anyways, number of attributes. Okay, we're gonna look at them in the coming cells, inshallah. Okay, these are the this is the data. Here we start with the first example here. We want to depict category column by count. So we want to plot a count plot for category column here. Okay, and also we want in another plot to depict category counts differentiated by type. So for the first one, we're just plotting bar plot, count plot. Okay, which will generate bars, right? The here y is equal to get category. That means y will be the value and x will be the frequency. Okay, the choice of the category, and x will be the frequency. So the bars will be horizontal here. Okay, so here in this figure, we're like for different categories or choices for this specific column or attribute, for each one of them, we will have one bar. Okay, so for every one of them, we will look at the frequency of the occurrence of that one. Let's look at the first one first here. So there are different choices or categories for this category column. For example, family here has the highest frequency. Okay, so most like the one that has like appeared the most is family. Now what happens here? Now we want for the second figure. So we want category to be differentiated by type. Okay, so what's that supposed to mean? Okay, let's look at how we do it here. So actually, let me explain what it means first. So category differentiated by type. So for example, if we take here, one category here, family, here we are plotting the frequency of family, how many times it has appeared. But now we want to differentiate it by the value of the other categorical attribute type. This has two choices. Okay, it has two choices, paid or free here. Okay, there is free or paid. Okay, then every bar here will be replaced by 2 bars in the second figure here. Why is that? So as I said, take example family here. So this is this like represent the statistics of the family category. Okay, so it's the total number of the occurrences, but actually we want to differentiate it by the type of the for those occurrences, and some of them the type was paid and some the type was free. So what we are doing here, we are splitting this set to 2 subsets. Okay, the subset where the value for type is free, and the subset where the value of type attribute is paid. And we're plotting the statistics of those separate from those. So we're plotting the statistics of paid separate from free. So 1 bar, or the frequency of paid, separate from frequency of free. 1 bar for the paid application, the paid family applications, and 1 bar for the, sorry, this is the free. Okay, the blue one is the free. 1 bar for the frequency of the family applications that are free, and 1 bar for the frequency of the family applications where the category is family and they are paid ones. Okay, so that's why every bar here will be replaced by 2 bars here. In general, every bar in this one, the one we are plotting the frequency for, will be replaced by as many bars as the number of different choices or categories for the second attribute for this one. And here we are using the hue in order to make that like differentiation. So we will give different colors to different bars. That's what happened here. Different bars have different colors. Okay. So here, as I said, we pass y equal to category. So then y will be the value and x will be the frequency. And then hue will split, like will differentiate by the new, by the other variable. So we will have here, in this case, we will have 2 bars for every category. We actually, yeah, we could have also do it x, but just, and so I always prefer looking into vertical bars. But now the problem is that it will look awful here. So the text, then we need to rotate those texts. Okay, this is already rotated. Okay, so we can actually, because we have used it here. Yeah, we can also use that here. Oh, it's already here commented. Okay, so yeah, now x is the value and y is the frequency. Okay, and each category, like for the second plot, each bar is replaced by 2 bars, as I said, okay, to represent the paid as well as the free applications. Okay. Okay, so yeah, we go to the next one here. So draw a box plot of installs versus rating. Okay, ordered by installs. Okay, so installs here is categorical because it has that plus sign there. Okay, there are categories. There are like different, like a limited number of elements. Okay, and rating is what? Rating is numerical. So when we have a categorical attribute and numerical attribute, we use box plot. Okay, so we will plot the statistics of the numerical attribute differentiated by the different categories or choices for the categorical attribute. So the numerical attribute here is rating, and the categorical attribute is installs. So for every category, we will have 1 box plot. For every category of installs, we will have 1 box plot for rating. So that will plot the statistics of the elements or the entries or the samples in which the installs falls at in that category. We will look at that when we generate the figure. But before that, let me explain this here. So in order to plot this relationship, we want it to be sorted out. So we want to start with the minimum number of installs and go this way. So go in an increasing order in the x-axis. So in order to do that, so what we do, we created, what we did here, we created a new column. Okay, that this column is nothing but the numerical version of this one. Okay, because as I said, this is not the numerical here because of the plus sign. Okay, so we created a new numerical column by removing the plus sign from this. So we apply this function here to the content of this column. So this function removes the plus sign and converts that to a numerical attribute by calling this function here. You see, we have applied dot apply, and after that dot apply again. So to change the type of the, because removing the plus sign will not convert the column to a numerical column. So we have to convert it to a numerical column. And in fact, we used to do it by just passing this to integer, right? It does the same thing here. Okay, we could have done that. Okay, and remove this. That will do the same thing. Okay, but let's do it this way. Okay, so this is another, just like to show you that this is another way to do it by calling the function apply pd dot to numeric. So now we created this column. Now we can actually, if we sort the elements, okay, the elements that we are, all the elements here, if we sort the elements by the value of this install numeric, then they will be sorted. Okay, because this is nothing but a numerical version of this one. They will be also sorted with respect to this. Okay, because if we sort with respect to this, we will have an issue. I will explain it when we look at the figure. So that's it. So we are plotting. So in conclusion here, or in summary, we are plotting the statistics of this attribute, which is a numerical attribute differentiated by the different choices or categories of this categorical attribute, and we are sorting based on the values of this attribute here, which is nothing but the numerical version of this. Let's look at this here. This is it. For every category here, okay, these are the different categories, 1 plus, 5 plus. For every category, we plot the statistics. Let's look for this one. For this category, for example, the category of the applications that have been installed 100 plus. So for that category, for the entries that in which the element for this category is equal to this, we are plotting the statistics of those. This is the statistics of the apps. This is the statistics of the rating attribute for the applications that were downloaded 100 plus times. Okay, it's not the statistics of the rating attribute, the overall rating attribute. No, it's just the statistics of the rating attribute for the entries in which the number of installs is 100 plus. Okay, and yeah, the same to each one, to every one of these. So if we, okay, so why we have sorted by the values of this install numeric. If we sort by the values of the original one here, installs, then this will be sorted because now they are taken as letters. Okay, so the sorting will be like this. So 1 comes before 5. Okay, so alphabetically ordered. So then all values with 1 will come first, and all values with 5 will come after that. So it's not really sorted in the number of installs. Okay, that's why we created this numerical attribute. Okay, in order to make this sorting. Okay. Okay, so and as you can see here, these are rotated 80-degree here. Okay, so this just to specify that, because if we don't rotate, the text will overlap, as you will see here. Okay, so that's it. We can rotate 90-degree, that will be perpendicular. Okay. Okay. Okay, now we go to the next example here. Okay, so here we are introducing another visualization tool called volume plot. Okay, so let's first read here. Draw a volume plot for of content rating versus rating. Okay, versus rating columns differentiated with respect to the type. Okay, so rating is what? Rating is the numerical attribute. So we will plot the statistics of this numerical attribute differentiated by the different categories or choices for content rating. So content rating will be the x-axis, and y-axis will be the the rating. So why if this is a box plot, then the boxes will be vertical. Okay. So, but this, we will look at what this is actually. Okay. So we are plotting the statistics of this attribute, which is a numerical attribute differentiated by the different choices or categories of this categorical attribute, and also by the type. Okay, we use hue for the type because now we have used all of them, X, Y, and the hue. So Y, to plot the statistics of this uh, attribute, which is a numerical attribute. X-axis, it will differentiate the different, we will have one statistical plot for each choice of this, for each category of this categorical attribute. But actually, on top of that, we have a hue equal to type. So we will not have only one statistical plot per category. We will have as many as the number of different choices or categories for type. And for type, there are two choices or categories, paid or free. So we will have two statistical plots for rating per category in this categorical attribute. Let me plot it, and we also gonna talk about, let me do it with, okay, let me plot it first. Maybe let me, okay. So we are doing it in two ways. We are doing it with vinyl plot as well as box plot. So for box plot, what we will have here, we'll have two box plots, okay, per category. We have two box plots for rating per category for content rating. Why two? They are because the type category has two choices, free and paid, and they will have two different colors. Let's look at that. Okay, let me look at the box plot first before I show you here. This is two box plots. Okay, for rating. Why? Because for every category there are paid and free. For example, for this choice for content rating, everyone, there are some free and some paid. Okay, so this is the statistics of the free. This is the statistics of rating for free apps in this category, in the everyone category. Okay, these are the statistics of rating attribute for paid apps for paid apps and content rating and everyone content rating, or the where the content rating value is everyone. Okay, so here we use free and paid to have to create these two plots for rating for every given category here. Okay, so now, okay, then what is violin plot? This is box plot. Okay, here's violin plot. Okay, violin plot is similar to box plot. It's just offer more information compared to box plot here. It's the same idea. It offers the information that are offered by box plot and add on top of that some information. For example, here, if you look into this, this is the position of the median, or the level of the median. Here is the upper quartile, lower quartile, upper whisker limit, lower whisker limit, and everything below that is an outlier, and below the lower whisker limit and higher the upper whisker limit is an outlier. But it actually tells you more about the distribution of the attribute. So if you look here, this tells you like there is more data at this level here than any other level. As we go upper or lower, the number of data samples or points decreases. Okay, so for this one here, it tells you like there are more data in this level and than any other level. So you can actually look where the data is distributed. So here in the box plot, the width has nothing to do with how many samples are there in that level. The width is constant here at every level. But here the width is actually telling you where most of the samples are, okay? At every level, like for example, here at this level has a higher number of samples. As we go higher, as we go upper or lower, the number of samples is decreasing. Okay. Yeah. So let's go to the next one here. How many ones are left? Okay, 3. So this one here. Okay. So we are plotting a bar plot, okay, or count plot, okay, for category that have installs above 0.5 billion. Okay, so there are two satisfying that condition, 500 billion and 500 million and 1 billion. Okay, so we extract this slice because we are concerned, or we want to plot the statistics only of the for the category. Okay, but only for the applications that were installed above this value. Okay. Okay, so then these are the two installs, or two categories or choices for installs that satisfy this condition. Okay, so then we extract only this slice defined by this condition. Okay, we use or here, we could have also used as in. So we're extracting only those ones, and for this extracted slice, only for this extracted slice, we plot the bar plot for the category attribute, and that's what we get here. Okay, so as you can see, the category has this many categories or choices. Okay, and for every one of them, we plotting the bar plot, but this is only for the apps that have been installed more than 0.5 billion times. Now we come to, okay, so here we get to know another visualization tool called Swan plot. Swan plot is very similar to violin plot and box plot. Let me just run it and show to you. Okay, though I feel like box and violin are okay. It's okay. Yeah, it's actually telling you where are the positions actually. So here for this one, for this category, if you plot a box plot, then the box will start here and it will end here. But you're not gonna know information about where the samples are. Here it's actually plotting you where the samples are. So if I add box plot on top of this, you will see what I said, what I was saying here. You see here we have box plot here. So it starts here, ends here, but actually the samples are at the here at the beginning and at the ending. There are no samples in the middle. So with Swan plot, we knew that. Okay, so we knew where the samples are actually. Okay, okay, that's that's a Swan plot. Okay, so we already know like Python plot and box plot. Okay, so we come to the last cell here. For all paid apps, then we want to extract only the paid apps here. Okay, because actually we are already using the 3xy. Okay, not really. Okay, so anyways, we are extracting those paid apps here. Okay, we want for only paid apps, and if we need like we are interested in a specific category, then we are not like differentiating by, but we are interested in the elements that belong to a certain category, then we extract that slice. So we are extracting the entries in which the type is paid. For paid apps, depict genres by count. So we want count, we're gonna plot a count plot for genres here. Count plot, y is equal genres, can be y or x. So here, if y is equal to genres, then the bars will be horizontal because x will represent the frequency. Okay, differentiated by count rating. So we know this now. So then we add the hue to make that differentiation, right? Y is already used it for the values, and X for the frequency. Then we introduce the hue to differentiate by content rating. Okay. These are, both of them are categorical attributes here. So that's why we use count plot here. Okay. So we are using that only for the extracted slice here, in which the type is paid. Okay. That's for the first figure. Let's look at the first figure first. This is it here. Okay. Yeah, there are so many categories here. Okay, this is the differentiations by the content rating. So they are given different colors here. For every bar, you will have at most this number of subbars. You may not have some of them if for example, for a specific genres, there is no, the content rating doesn't get one of these values, for example. So then so at most you will have 4 bars in the second figure. No, it's the same figure. We're not plotting. Yeah, it's one figure here. So at most you will have 4 bars for every category in genres. Okay, you may have less, as I said. Uh, for the second one, differentiated by content rating. In another plot, depict genres by rating. Okay, so the content rating is categorical. So both are categorical attributes. That's why we used count plot. But now rating is a numerical attribute. So we use box plot. So we plot the statistics of this numerical attribute rating differentiated by the different choices or categories for this attribute genres. And this is what we get here. And here, because X is equal to rating, then the box plus will be horizontal. Okay. This is what we get here. Different box plots for different choices. We could have also do it this way, right? X equal to this and Y equal to that. We did this actually for another, in another cell, like maybe there was another categorical attribute. Okay. So we can rotate this here. If we do it X, then we can, let's rotate this here. The X lab, okay, here. Like that. And this is what we get. Okay. Yeah. Maybe for this one, it's too dense, right? Maybe flipping it is like making this Y and that 6 can be visual, like visually better. But anyways, the idea is clear, right? Hopefully. Okay, so with that, we come to the end of this topic. Next time, inshallah, we will start a new topic. Thanks for watching and see you next time. Assalamu alaikum.